Example 14.10c gives us a new function. This is function g, and it is given to us in a standard form equation. So let me write out the end behavior. The end behavior will be y approaches negative infinity as x approaches infinity, and also y will approach positive infinity as x approaches negative infinity. That can be found by looking at negative x to the fifth. That is the leading term, although it is not written first. It is the term that has the highest power on the variable, so it is the leading term. Your x-intercept calculation is going to give you 3 unique x-intercepts. You will have the origin again. It's a very popular x-intercept. The square root of 3 comma 0, as well as the negative square root of 3 comma 0. And we've seen how multiplicity plays a huge role in the way the graph is executed. So let me give you that information. The origin has multiplicity of 1, positive square root of 3, and the negative square root of 3 both have multiplicity of 2. Remember that there's a conjugate pair theorem that discusses that every time we have a irrational or a complex 0, they have to come in a conjugate pair. So this is why we have both square root of 3 and negative square root of 3. And they would also both have to have the same multiplicity. You can't have one with multiplicity 2 and the other with multiplicity of 1. That means you wouldn't have them paired up correctly. So now onto that y-intercept calculation, 0, 0. And for the symmetry, you will calculate that, that g is an odd function. And if g is an odd function, then this means that we will expect to have origin type symmetry with this graph. Let's plot the points. 0, 0, square root of 3, and your calculator will tell you that's approximately 1.7, and that'll be certainly sufficient for graphing purposes to approximate about where it is. And then we'll also have negative square root of 7 there, or 1.7, sorry. And then 0, 0 was already there from the x-intercept. So end behavior is the next thing on the list. Right-hand side is supposed to be going down, and the left-hand side is supposed to be going up. And now it becomes a matter of connecting the dots. So for connecting the dots, the left end behavior starts with us going down toward the x-intercept at negative square root of 3, where we have a multiplicity of 2. Now, for this multiplicity of 2, we're going to have to create a little relative minimum here, since we're coming in from above the x-axis. So let's come down to connect to that relative minimum. And that keeps me in the second quadrant. And now I want to get over to the origin, and the origin is going to be just a simple crossing through because it has multiplicity of 1. So I'm just going to go up a little bit, make a nice smooth turn, and then come on through and cross the origin. And that puts me into the fourth quadrant now, which is what I would expect when I have origin symmetry. So origin symmetry is a rotational type symmetry, and it's essentially 180-degree rotational. This means that whatever is happening in the second quadrant is going to also be happening in the fourth quadrant. That also means if there's nothing going on in the second quadrant, sorry, this is the first and the third, excuse me, if there's nothing happening in the first quadrant, then there's nothing happening in the third. But at the same time, if you have anything going on in the second quadrant, that should be the same as what's happening over here in the fourth quadrant. So since we've already completed the second quadrant and we're moving into the fourth, we should be able to mimic what we have, and it'll be kind of the opposite though in the way that it mimics. So we're going to end up having a relative maximum over here at the square root of 3, and then we'll make the little turnaround and come up, and now we can finish going down until we get to the right end behavior, and this gives us the graph of G.